Okay, so we just saw how to start filling in these orbitals, how to figure out orbitals. So we are going to we're now going to learn how to write an electron configuration. So the first thing you got to remember that you start with 1. Do 1s. And when you put 1s, make sure you write the number, like the total number that can go in the top right here. That one is how many electrons are in it, right? And so first you give me the energy level. That's 1, 2, 3. Then you give me the second part. That's that sub-level. And then you give me the number of electrons. So you need the 3 things. Energy level first, then its sub-level, then the number of electrons. So sub-levels are filled in order of increasing energy. This is just the Aufbau principle. Sorry, I have a problem saying that. The Aufbau principle. You got to go in order. So first the 1s, followed by the 2s, followed by the 2p, and so on and so forth. Superscript numbers add to give total number of electrons in the structure. So these numbers are the electrons, right? Okay, we're going to practice. I know that was really, really quick. So we are going to do the configuration for an atom containing 22 electrons. So the first thing we got to do is we got to start adding things up. We are going to start off with the 1s. So we do 1s, and there is 2 in there. So I have 22. I'm going to minus 2, so I've got 20 left. So I'm going to go to the 2. Let's do 2s. 2 minus 2. We've got 18 left, right? Let's go to the next one. The next one is 2p. And p can hold 6. So I'm going to put 6 because I definitely have more than 6 here. So I'm going to take away 6, and I've got 12 left, right? So let's go next. The next thing we have is 3 because we only have 2 sublevels for that one. So let's go to 3s. There are 2 in 3s. Minus 2, so I'm left with 10. All right, let's go 3p. There are 6 in that, right? Because there's always 6 in the p. So 10 minus 6, that gives me 4. So I'm going to do 3d, and d has 10 in it, and I only have 4 left. So I'm going to put the 4 left over in the 3d part. So let's see. Oh. Oh, that was my bad. I made a mistake. So you're going to do only fill 2 of the D first and then add the 4S. That was my bad. It's been a little bit of a time since I've done this. So make sure you put the S in after the 3D2. All right. Write the configuration for an ion plus 3, iodine plus 3. So iodine has this right here. It's a lot. It's definitely a lot. So for us to do this, I'm going to take the, I think it's easy way. Let's see how I did it. So iodine has 53. Normally, with the plus 3, remember that means there's 3 more positives than negatives. So I'm going to subtract 3 from that. There are 50. That's a lot. This was just 20 right there. The 3D24S2. That's a lot. Like that's 20 right there. You need like 30 more. That's a lot. So that's what it would look like. We're not going to go that far. That's just mean to do. See, you filled the 3P, 3D, 4S, 4P, 4D, 5S, 5P. I'm not going to try and go that far. If we do, I'll show you little tricks to that. All right, now we're on to my favorite, electron dot diagram, Lewis dot structures. So these, I love these. I think they're fun. I don't know. You might like them. So this shows the valence electrons. Now, what the heck is a valence electron? Well, electrons occupying the outermost level, the very, very outside level, which is called the valence shell. Those electrons are involved in bonding. We're not there yet, but this is for when we get to bonding. Dots. Dots represent electrons, and they are placed above, below, to the left, to the right of an element symbol. S electrons are typically placed at the top or right position. Pretty much, I'm going to say start at the top, work your way around. So looking at this is what I was talking about. Above, below, to the side, to the side. X is the kernel. That's the nucleus. That's got all the inner electrons, the protons, and neutrons, everything on the inside that we don't have to worry about. We're just looking at the outside right now. And the two dots on the top represent a pair of electrons in the S sublevel of the same orbital, the F2 principle. Right now, we're just going to look for how many's on the outside. The three dots at the right, left, and bottom represent 3 electrons in the P sublevel, each one in a different orbital. This is Hund's rule. So, okay, Miss Co, why doesn't the X look like this? Well, this goes into the octet rule, which we're going to get to. Right now, just know that when you start filling up, you're going to fill up going in a circle. You're going to start here, and you're just going to count however many, and you're going to keep going in a circle. All right, so we're going to look at aluminum. Aluminum shows a simple configuration of 2, 8, 3, meaning this 3 right here, there are 3 in the outer level. That's in the valence shell. The Lewis structure should have 3 dots. The electron configuration would be this: 1s, 2s, 2p6, 3s2, 3p1. A pair of dots should be placed at the top of the symbol and a single dot at any one of the other 3 positions. Your choice. So in this case, you have aluminum, Al, with 2 dots at the top and 1 at the side. All right, so exercise. What is the valence shell for oxygen, and how many electrons does it have? So we're going to look oxygen right here. Oh, my finger's in the way. It says 2, 6 right there. Oxygen. 2, 6. 2-6 for oxygen. Right? Draw an electron dot diagram for oxygen. So oxygen right here. And honestly, this is how I'm going to do it. I know the notes are a little bit different. I'm going to do 1, 2, 3, 4, 5, 6. That's how I would draw it. Why does it say the valence shell's 2? No, the valence shell, it's sublevel 2. There are 6 valence electrons. So I'm looking at the last number. There are 6 in the outer shell. So I'm going to, just like I showed you, do this. All right, draw the electron dot diagram for a silicon plus 2 ion. So Si, silicon, has 2, 8, 4. And because it's a plus 2, that means I've got to take 2 away. So this is going to be a 2. I'm looking at that last number right there. It was a 4. It's now a 2. So my silicone, Si, is going to be 1, 2. Right like that. It could be also done as this. Right there. Okay? See what I've got? Right there. And you want the plus 2? Just to denote that 2 were taken away. 2 electrons were taken away. All right, here's some exercise. For an atom of ion, draw the following configuration by shell, by sublevel, and the electron dot. So by shell, what does it look like by shell for the iron? Iron is Fe, and that is right there. Number 8 are in group 8 right here. And it's got a 2, 8, 14, and 2 by sublevel. This is a bit long, so I'm going to stop at argon. I'm going to start with argon, so it's 2, 8, 8, and I'm going to continue on from there. Again, I'm not going to go into making you guys do sublevels for anything past D, because it's just me. All right, electron dot. This is my fun one. There are 2 in the outer shell, so Fe. You could either have either of these. Okay? All right, so we're going to fill out the worksheet. We're going to do electron arrangements. If you have any questions, please let me know, and I hope you guys have a great day.